Welcome to How to Succeed in ECE Without Really Trying. I'm Dr. Linda DeBrunner, and in this video I will talk about how to analyze an AC circuit using techniques from passive filtering. We will do a simple example. Okay, what we'd like to do here is calculate the transfer function V out of S over Vn of S. And then we will solve for a particular V out of t given the input Vn of t is equal to 3 cosine 2 pi 60 t plus 45 degrees. We will also solve for IR of t. You could do this problem just doing circuit analysis with the complex values, but this is showing you an alternate approach. Okay, so let's go ahead and we will do nodal analysis on this problem. It seems to be the easiest to me. We'll have a node here, and that node is V out. This node here is actually V in, and of course we have ground at the bottom. So if we do voltage, if we do nodal analysis at this node, then what we're going to have is V out minus Vn, and I'm doing this all in the S domain. So V out minus Vn over the impedance SL plus V out minus 0 over R plus V out minus 0 over 1 over SC, and that will be equal to 0. So I can move the Vn to the right-hand side and factor out V out on the left-hand side. So we'll have V out times 1 over SL plus 1 over R plus SC, 1 over SC, 1 over SC is SC, and that will be equal to Vn over SL, and I'm being very careful to make sure I get my signs correct. If I take this equation I have here, and I multiply this whole equation by S times L times R, then what I will end up with is V out is equal to times SLR over SL gives me R, SLR over R gives me SL, and then for the last term, SC times SLR gives me S squared RLC, and that will be equal to Vn times SLR over SL, which is Vn times R. Okay, if we solve for V out over Vn, okay, and of course we're in the S domain here, we will end up with R over S squared RLC plus SL plus R. So we have found the transfer function. This is what you would have done in our section on passive filtering where we solve for transfer functions. So now, this is still a true statement, of course, but now we want to consider what happens when our input is going to be this particular value, a particular sinusoid. Okay, and what we note from this is that the frequency of omega is equal to 2 pi times 60. From this part here, the transfer function, we get V out of S, and we'll plug in some over Vn of S, and we'll plug in some specific values we have listed over here. Plugging in those values and just simplifying gives us 100 over 0.0006 S squared plus 0.2 S plus 100. Okay, so I'm going to give this a name H of S just so I can write it. Now we can take this Vn and we can write this now as 3 at an angle of 45 degrees volts. And this will become useful in a moment. So what we need to do at this point is from this equation, we're going to substitute S is equal to J omega, which is 2 pi times 60. And we'll end up with H of J 2 pi times 60 will be equal to 100 over J squared, of course, is minus 1. So we'll have 0.006 times 2 pi times 60 squared. And J squared is a minus 1. Plus 0.2 times 2 pi times 60 plus 100. When we plug in the specific values and solve, you can do this either, of course, on MATLAB or using your calculator. I end up with H of J times 2 pi times 60 will be equal to 100 over, the denominator when we simplify shows up to be 14.7266 plus J 75.3982. And when we do this division, of course, this is just a real number divided by a complex number. So you can, again, do that in your calculator. I end up with 0.2495 minus J 1.2776. Now, at this point, we can write this as a phasor. Even though it's a transfer function, you can still write it as a phasor. And when I do that, I end up with 1.3017 at an angle of minus 78.9482 degrees. And of course, the units are no units because we're doing a voltage over a voltage. Now, at this point, I know this seems like a lot of convoluted work, but at this point, we have H at a particular frequency. Recall, of course, that, let's see, Vn was equal to 3 at an angle of positive 45 degrees is volts. So H of J 2 pi 60 will be equal to, of course, just a reminder, V out over Vn at the same exact frequency. Now from this we know that V out at that frequency, 2 pi 60, will be equal to H at that particular frequency times Vn at that same frequency. So that will tell us that V out will be equal to 1.3017 at an angle of minus 78.9482 degrees times 3 at an angle of 45 degrees. When we do that multiplication, we end up with 3.9051 at an angle of minus 33.9482 degrees. And the units, of course, is volts. So at this point, it's a good time to check to make sure we didn't make any careless mistakes. When we take 1.3 and multiply it by 3, we do end up with something close to 4. And when we take minus 78 and add 45 degrees, we end up with minus 33 degrees. The last thing we need to do is write it as a time domain signal. So we have V out of t for the particular input of 3 cosine 3 times cosine of 2 pi 60 t plus 45 degrees. At that particular frequency, we end up with V out, and so of T will be equal to the magnitude, 3.9051, cosine omega, of course, is 2 pi times 60, so 2 omega t, and the angle is minus 33.9482 degrees. And of course, the unit is volts. Now, if we go back to our initial question, we wanted to know what the transfer function was. We found that. We found out what V out of t is for this particular input Vn of t. And the last question is, what is IR of t for this particular Vn of t? When we look at this circuit, we can tell fairly simply that the current IR of t through this resistor will be the voltage divided by R. So we can simply write for the part C, so this is part B. For part C, we write IR will be equal to V out over R. And it doesn't really matter whether I write this as a function of S or as time, but from at the final end, we want the time function IR of t. So we just multiply the amplitude by R, which is 100, and we get 0.0391 cosine of omega, which is 2 pi times 60 t, and the angle doesn't change. The units, of course, is volts. Oh, sorry, the unit, of course, is not volts. The unit, of course, is amps. So always be careful to make sure that you get your units right, that you've got all your multiplications in the right order. I hope you found this example helpful.